CORBES mission, developed by the Small Geostationary Radiation Belt, SGRB division of the TGCSS, is a CubeSat constellation advancing the study of Earth's radiation belts in alignment with the COSPAR Science Roadmap for small satellites in space science. After 2 years of development, CORBES aims to conduct a high-tempo investigation of Earth's radiation belts. Designed to monitor changes within the radiation belts, CORBES operates similarly to Geostationary Transfer Orbits, GTO, maintaining an equatorial orbit with an apogee of approximately 7 Earth radii. Deploying multiple satellites in this orbit allows CORBES to differentiate spatial from temporal radiation belt variations, significantly enhancing our understanding of these dynamic zones. Each satellite is expected to operate for at least 1 year, ensuring cost efficiency and mission continuity. The CubeSat constellation gathers detailed measurements of energetic electron flux, geomagnetic field shifts, and plasma waves to deepen our knowledge of the outer radiation belt's dynamics. This data sheds light on key physical processes affecting radiation belts, including energy diffusion, triggered by local resonant electron interactions with very low frequency, VLF waves, such as Whistler mode waves, especially during geomagnetic storms. Pitch angle scattering, resulting from interactions between electrons and magnetospheric plasma waves, including Whistler hiss and electromagnetic ion cyclotron, EMIC, waves. Radial transport, driven by drift resonance with ultra-low frequency, ULF, waves, and sudden electric field changes, caused by large-scale magnetic field shifts, such as shock-induced injection and storm convection. Electron escape, occurring when electrons exit the magnetosphere into the solar wind through magnetopause shadowing and other outward radial transport mechanisms. This comprehensive analysis will enable CORBES to improve scientific models and predictive tools for radiation belt environments by better understanding electron transport, acceleration, and loss mechanisms. Each CORBES satellite carries a suite of 3 primary instruments: a magnetometer, MAG, a search coil wave detector, SCWD, and a high-energy electron detector, HEED. These instruments operate in highly inclined elliptical orbits with a perigee of 280 kilometers and an apogee reaching 7 Earth radii on approximately 13.5-hour orbital cycles. During each 10.5-hour pass through the outer radiation belt, the CubeSats collect precise data on magnetic fields and electron populations. Spin stabilized with around 8 rotations per minute, each satellite's sun-facing axis ensures stable orientation. At 30 kilograms per satellite, the mission is designed for efficiency and cost-effectiveness. Communication and data transmission use the S-band for command functions and the X-band for downlink. The satellites will be deployed using 1 or 2 rockets, with coordinated release for precise orbit insertion. The assembly, integration, and testing (AIT) process emphasizes radiation shielding and cross-calibration. On-orbit cross-calibration ensures data consistency by aligning readings from multiple devices under specific conditions. For instance, HEED's cross-calibration uses electron selection data during quiet magnetospheric phases, while MAG and SCWD measurements are verified using calm period data. International contributions enhance CORBES, with partners such as Harbin Institute of Technology, HIT, the Innovation Academy for Microsatellites, IMAC, and Finland's FORSAIL program, each adding to satellite technology. IMAC has provided 2 satellites and instrumentation contributions from the National Space Science Center, Beijing University, and the University of Turku, ensure a robust equipment array supporting the mission's objectives. CORBES operates under a data-sharing policy, granting open access to its collected data, aiding the global research community in understanding magnetospheric dynamics. COSPAR has supported CORBES's mission organization, coordination, and partnerships with academic and governmental institutions. With over 40 collaborative meetings to gather input from scientists worldwide, CORBES, with COSPAR's support, seeks to answer key questions about wave-particle interactions and radial transport within Earth's radiation belts, marking a significant advance in space science.